we have 4 different types of number system, that is decimal, binary, octal and hexadecimal number. So whatever the decimal number I'm going to have, for that I'm going to divide that number by 2. While writing, I want to start from MSB, that is most significant bit, to LSB, that is least significant bit. Hello to all, a warm welcome to my new session on number system. I'm Revati from the Department of Computer Science, Vidhyaashram, first grade college, Temple of Excellence, MYSURU. So dear student, before going to start my today's session, let me to recall the things what I have discussed in my last session of this unit. So I started with introduction. Along with that, I have covered types of number systems, that is binary number system, decimal number system, hexadecimal number system and octal number system. But in my today's session, at the beginning, I'm going to deal with number system conversion. Along with that, I'm going to deal with decimal to binary. These are the topic I'm going to deal in my today's session, and from the examination point of view, the number system conversion is very important. Now, at the beginning, I'm going to have number system table. So, as I discussed, we have 4 different types of number system, that is decimal, binary, octal and hexadecimal number. Now, if I consider decimal number, so what is the range? It is 0 to 9. And if I consider binary, I'm having 0 and 1. And if I consider octal, 0 to 7. And if I consider hexadecimal, it is 0 to 15. And if I consider decimal number, that is 1 to 9. And if I consider binary, I have only 2 bits, that is 0 and 1. And whatever the decimal number or octal number or hexadecimal number, I want to represent that in the form of binary. For that, what I will do, I'm going to divide that number by 2. So dear student, let me to consider decimal number, that is 5. So 5, then I'm going to divide this number by 2, that is 2 2s are, it is 4 and 1 remainder, and 2 1s are 2 and 0 is remainder. And while representing this decimal into binary, so I'm going to have 1 0 1. So here 5, it is 1 0 1. And if I consider 9, same thing. Write the number and divide that number by 2. 2 4s are 8, 1 remainder. 2 2s are 4, 0 remainder. 2 1s are and 0. So how to write? 1 0 0 1. So here I'm having 1 0 0 0. And if I consider octal, 0 to 7, I can have octal number. And if I want to represent 8 in the form of octal, 8 divided by 8. 8 1s are 8, 0 remainder. So it is 1 0. For 8, I'm having 1 0. Now, if I consider hexadecimal, then I'm having 0 to 9. After 9, to represent 10, I can have A, B, C, D, E and F. So in hexadecimal, 0 to 9 and A for 10, B for 11, C for 12, D for 13, E for 14 and F for 15. So this is my hexadecimal representation. And if I consider decimal number 14 and how I'm going to represent in the form of octal, that is 14 divided by 8. 8 ones are 8, 6 remainder. So it is 1, 6. And if I consider binary, then it is 14 divided by 2. 2 sevens are 14, 0. 2 threes are 6, 1 remainder. 2 ones are 1. So it is 1, 1, 1, 0. So 111, 0. Now I'm going to have conversion, that is decimal to binary. I have decimal number and I want to convert that to binary. And how I'm going to convert? What is my step? That is, I'm going to divide that number by 2. So whatever the decimal number I'm going to have, for that I'm going to divide that number by 2. Now, in my next step, I'm going to consider the remainder and record it on the right side. So, after dividing, whatever the remainder I'm going to get, I'm going to write in my right side. And I'm going to repeat this step, that is 1 and 2, until the decimal number cannot be divisible by 2 further. Then first remainder will be the LSB and the last remainder will be the MSB bit. So that is least significant bit and most significant bit, and the equivalent binary number is then returned in the form left to right. So while writing, how I'm going to write? Left to right, that is from MSB to LSB. Now let me to consider the example here. I have 87 and so here 87 divided by 2. So 2 fours are, it is 8, 2 threes are 6. I have 43 and 1 is remainder. Now once again I'm going to divide this number by 2. So 2 twos are 4, 2 ones are 2, 1 is remainder, and once again I'm going to divide this number by 2. 2 tens are 20, 1 remainder. Now 2 fives are 10, 0 remainder. Now 2 twos are 4, so 1 remainder. 2 ones are 2 and 0 remainder. And while writing, I want to start from MSB, that is most significant bit, to LSB, that is least significant bit, and this is my final output. Now I'm going to have fractional number to binary number, that is decimal fraction number to binary number. If I get any fractional values in my decimal number, to convert that into binary, what I want to do? I want to multiply that number by 2. Now, note down the carry as well as product and repeat the step 1 and 2 until the decimal number cannot be divided further, and first carry will be the MSB and last carry will be the LSB, and while writing I want to write from MSB to LSB. Now dear student, this is the example I'm going to have here. So at the beginning what I want to do, I want to multiply this number by 2. After multiplying, I'm going to get the carry 0 and product is 0.25 into 2. So I'm going to multiply this number by 2 once again. So I'm going to write the carry, and what about my product? That is 25, that is 0.25. So this is my product. Now what I'm going to do? I'm going to multiply this 0.25 into 2. So I'm going to get 0.50, and my carry is 0. And what about product? That is 0.50. Now I'm going to multiply this number by 2. So I'm going to get the carry 1, and I'm going to get the product 0. So this is the way I can able to convert a decimal number to binary. Now let me to consider one simple example that I have 0.25. So what I want to do? I want to multiply this fractional value with 2. 2 5s are 10, 1, 2 2s are 4, 4 plus 1, it is 5.0, because I don't have any carry. So here carry is 0 and product is 0.50. Now 0.50 into 2, 0, 2 5s are 10 and 1 carry, and where I'm going to write this 1 in the place of carry. And what about product? That is 0, 0. So this is the way I can able to convert fractional number to binary. So dear student, this is all about how to convert fraction number to binary. Now let me to consider another example here. That is, I'm going to have the number 0.3125 and I'm going to multiply this number by 2. So 2 5s are, it is 10, 1 carry. 2 2s are 4, 4 plus 1, it is 5. 2 1s are, it is 2, 2 3s are, it is 6. So what about my carry? It is 0. Now, if I go with second one, see here, this is the product I'm going to have, and I'm going to multiply that product with 2 into 0, it is 0. 2 5s are 10, so 0, 1 is carry. 2 2s are 4, 4 plus 1, it is 5. 2 6s are 12, so I'm going to write the 2 here, and 1 is my carry, and where I'm going to write in the place of carry, and this is my product, and this is my product. Fine. Now, dear student, I'm going to have 0.6250 and I'm going to multiply that by 2. So, after that, I'm going to get the output or result, that is 1.2500, and I'm going to multiply that by 2. So, 2 into 0, it is 0. 2 into 0, it is 0. 2 5s are 10, so 0 and 1 is carry. 2 into 2, it is 4. 4 plus 1, it is 5. 2 into 0, it is 0. So, carry is 0. And for the next step, I'm going to consider 5000, that is 0.5000, and I'm going to multiply. And when I multiply, I'm going to get the product 000, and I'm going to get the carry 1, and I'm going to place the binary numbers, that is from MSB to LSB. Now, I'm going to have another example here, that is 152 into 671875. So, here I am going to have integral part as well as fractional. So I'm going to have integral part as well as fractional part. So what I want to do, I want to consider first integral part and how I'm going to find the solution for my integral part. For that, I'm going to divide that number by 2. And what about my fractional part? Here, I'm going to multiply that number by 2. So here, 2 sevens are 14. Then it is 12. 2 sixes are, it is 12 and remainder is 0. Now, 2 threes are, 2 eights are 0. 2 ones are, 2 nines are 18, 0. 2 nines are 18, 0, 1. 2 fours are 8, 1. 2 twos are 0. 2 ones are, and it is 0. And what is the value here? It is 1, 0, 0, 1, 1 and 3, 0. And for my fractional part, what I want to do, I want to multiply this fractional part by 2. So, I'm going to multiply and I'm going to get this result, and this is my carry and this is my product. And if I consider next result, once again I'm going to multiply that number by 2 and I'm going to get the carry 0, and this is my product. And for the next step, I'm going to consider the product. So this is going to continue until when all my products are 0, then I'm going to stop the process and I'm going to club all the result together. So I'm going to write my integral part as well as I'm going to write my fractional part result. And how I'm going to write? I'm going to start from MSB to LSB. This is the way I can able to convert my decimal number to binary. So dear student, I hope in my today's session you got more information about how to convert binary number to decimal with the integral part and fractional part. In my next session, I'm going to deal with binary to decimal number, then decimal to octal number and octal to decimal numbers. Anyway, dear students, let's meet in the next session with more information about number conversion. Until that, keep watching and keep learning. Thank you.